We're going to start with a clean scene now and put what I've covered with the smoke solver and do a little bit more practical usage and create something a little bit more interesting. So we're going to create a geometry object, and let's name this object nitrogen tank. We'll dive inside. We'll actually keep this file here. Navigate to where the nitrogen tank model is. Select that guy. So that's our tank here. Go to the object level, and we're going to create our smoke container. Just hit enter and it'll put it at the origin. Go ahead and ghost our object so I can see. For what we're doing, we're going to do like a dry ice type effect, just kind of pouring out of these. You can see on this model they have these valves here, these 3 valves. We're just going to have some dry ice pouring out from there. So we don't need our container to be very big. Something around there is good. And let's create a ground plane so our smoke can collide with it. And in order for our smoke to collide with other objects, we need to feed it into this merge. This will now make it become a part of the simulation. And I'm going to reverse these inputs. This effector relationship on the merge stop is set to mutual. The other option is left inputs affect right inputs. Mutual means that it doesn't matter what order you have them plugged in, they should all talk to each other. But I think maybe it's just because when DOPS first came out, however many years ago it was, close to 10 years now, you always had to have your collision objects going into the left to be on the left side. And so I'm just in the habit of putting collision objects always on the left side, but I'm guessing you get the same result. Right, so we hit play and nothing happens because we haven't set up our emitter yet. Also going to set this to smooth shaded. So let's set up our emitter. Let's create a geometry object and we'll just call this emitter. Let's dive in. We can get rid of this file swap and let's create a sphere. Now that sphere is a bit too big, so we're just going to scale this down, translate this up. And I'm just going to put this right inside one of those valves. So we're going to need it pretty small. It'll just fit in there nicely. Okay, somewhere around there. Now I could create 2 more spheres and manually put them there, but let's make it a little bit easier on ourselves. Create a copy stop, and we want 3, and we want to rotate each of them 90 degrees. Put that one there. Oh, the other one I put right there. Negative 90 degrees. There. Alright. So we've got our 3 spheres now. And this is where we're going to be emitting our fluid. We could use the shelf button and say emit from object, and that'll set up everything, but I also think it's important to learn how to do these things manually. So we're going to put a fluid source down. Now you can see it's kind of given us this little hazy thing here. That's because our division size which is the resolution of our emitter, is too high. Our radius is this really small number, 0.008. So that means our voxel size needs to be smaller than that. Because right now, a voxel is, taking up like this by this by this. So this is a small fraction of a single voxel. So let's turn this division size to something like 0.01. Now to better see this, we can set this to something like 10. On the SDF from geometry, it's actually feathering the edge, and this is a distance value. This is far too great, so let's turn that down as well. Now if you remember from our previous example, when we originally set it up with the shelf button, it created a density field, but then we also had a temperature field. Well, right now we don't have that temperature field. We can see it's only creating the density field here. Well, under this container settings tab, one thing it's always important to do is these are like presets or built-in presets. Depending on what you're going to do, you just select the one and it'll automatically set a lot of these values that you need. Now it says source smoke. That's the default, but it actually hasn't initialized it until you select it. So it's best to just go to something like source fuel and then switch back. And it now automatically creates our temperature field. Oh, but it destroyed our... Oh, it kept this division size. That's interesting. But it didn't keep that, so we have to put that back. Okay. So you can see we have little clouds here. That's where our emission will take place. And then let's just create a null in case we want to add any nodes in between. It's always good, I think, to out emitter. Just to put a null here, because this is what we'll point to in our DOP network. So to bring our emitter in, to emit smoke from it, we need a source volume DOP. Now the path, this is the path to our SOP network. Emitter, out emitter. Now this has a similar thing for initializing all the parameters, setting up all the defaults. Again, just do something like that and go back to source smoke. So this will make sure that it's adding to our velocity, it binds all the parameters necessary, and kind of gets us up and running easily. Now emitters always go into the last input of the solver. This is the sourcing input or the post solve. So after it does all the computation, it then goes here and performs this step. Our box is still probably a bit too big for our needs. Set it to 2. Just get it under our ground plane. And we hit play, and all of a sudden, look, our box resizes to down here because it hasn't actually found any density. Well, there's a couple reasons for this. The main one is this resize container checks for, it looks at our density field, and if the density is below this value, it'll basically treat it as 0 or empty and won't resize around it. So that's one reason. The other reason is our resolution of our box is much too high, or actually it's too low. The division size is too high. The resolution of our sim is way too low right now. You can see these ticks here. This is showing what the size of a voxel is. So these voxels are huge. So let's set this to like 0.02. That way we'll get a few voxels where our emitter is, and therefore the resizing will work better. So if we hit play, we can see it's now resizing around it. Okay, we're seeing that it is resizing. but I'm not really seeing anything. Yeah. So, or whatever it is, it's so faint that can't even tell. So on our source volume, let's scale our source volume. This is essentially scaling the density up. Okay, and now we're starting to get some stuff, and it hits the ground and travels outward. I'm going to reset this guy back to 50. There we go. Now the other thing we can adjust on our resize is the padding. Right now, it's padding our simulation by a certain distance. To make this a little bit faster, we can decrease this padding because our density is existing in such a small area. Turn that to 0.05. Okay, we can see it's going much faster now. And our simulation is about the same. So we've set up the basic simulation. In the next class, I promise we will actually begin to add some turbulence and shape our simulation. All right, we have our smoke coming out, and it's actually difficult to see if I turn off hide other objects. You know, we can see this is kind of what we have right now, just at the default. So we need to make this a bit more interesting. Our temperature, even though our smoke is falling, just because our temperature is essentially 0 and then it's cooling off, so it's falling, let's go ahead and just make sure our buoyancy direction is set to -1. So this is what we have. It's pretty much the same as what we had before. So the first thing I'd like to do is introduce some turbulence. Now our smoke solver doesn't have any of those controls. None of these are really being used. This is stuff we don't need to really worry about. We don't have that functionality yet. But we can use a micro solver and feed it into the appropriate input to add additional features such as turbulence or dissipation, things like that. So we're going to create a gas, and if you type gas, you can see these are all the various micro solvers available to us. They all do various different things with fields, and there's quite a few different possibilities out there. Gas turbulence, that's what we want. And you can actually see this microsolver is actually made up of a bunch of other microsolvers. Because it's blue, you can see it's a digital asset, you can jump in, and it's creating a temporary field, and then in this gas field VOP, which is like a VOP pop or a VOP SOP, this is what's responsible for doing the turbulence. So we have this. This is going to modify our velocity. So we have our first input, which is our pre-solve. So what is happening with this guy? It's resizing the container, and then it's going through the next step of computing the velocities. So the third input here is velocity update, and we're using turbulence to modify velocity. So let's just plug that in here. This fourth input is the advection stage, which takes the computed velocity field and uses it to advect the density. So if you wanted to modify the advection stage, you could plug stuff in here. So hit play now. Not a great deal different. We're starting to get a little bit more kind of shapes happening. On our smoke, just so we can visualize it a bit better, under the multi tab, let's set density scale. Now this is strictly just visualization purposes. It's not actually going to modify the behavior, but just so we can view it a little bit better. On our gas turbulence, these are our turbulence settings. Scale is basically amplitude. If you were to turn this up, you can see it's having a much bigger effect. We'll keep that back here. Swirl size is frequency, but it's actually inversely proportional. So as you increase this, it's going to actually decrease the frequency. So this is kind of the size of swirls. So a swirl size of 0.6 is going to be much bigger than a size of 0.2. So if we set that to 0.2, it'll actually be a much higher frequency. Now the other thing which we haven't done yet is we need to bring in our nitrogen tank and use that as a collision object. Let's create a static object. So this will just allow us to bring in geometry to use as a collider. And again, because I'm old school, so to speak, I'm just going to make sure it's to the left. And so now it's colliding with our tank. So you can see that this stuff just kind of lingers, and dry ice kind of dissipates quickly because it's more just vaporous. We can also attach a gas dissipate microsolver. Now, in order to have both the turbulence and dissipate, because dissipate will affect the velocity stage, in order for us to be able to plug both these in, we need to create a merge. Now, the way the merge works here is it will work from left to right. So it will process the turbulence first and then the dissipate. But these two, you're not really going to see much difference if you swap them around. So we've got two different settings. The evaporation rate is how quickly to reduce the amount of density per second. So if we set this to 0.5, that means 50% of the density field will be reduced to 0. And this is over a second. So 24 frames in a second, and you can see now that out here it's getting reduced much quicker, but we could probably turn it up a bit more actually. So if we set it as something like 0.3, the other parameter here is diffusion, and this is how much you can actually blur the density field. If I turn the real-time toggle on, just so we get a better sense of how fast this is actually going. Oop. So a couple more things I'd like to do is our emission currently right now is just emitting smoke at a constant. We have some other features on our fluid source SOP. We have a noise tab, and by default that's ticked on. So we can view this a bit better. Now you can see it's still fairly low res, but we can use noise to kind of vary the emission. So cell influence, there's some cell noise which we can dial just to break up so it's not steadily streaming. The cell size is just like the frequency, so you can turn that down to get a higher frequency. Turbulence settings, element size is like your frequency, so you turn it down. You can see now it's not just kind of flickering because the noise frequency is higher. The other thing I'd like to adjust is the pulse duration. The pulse duration, there's a time offset to this noise, and this is kind of how quickly it cycles. So by setting it to 1 means it'll go through a full cycle in 1 second. By turning it to here, we can see it'll cycle through faster. This just adds a little subtlety to it, a little variance. Now we go to the velocity volumes, and right now we do not have a velocity field. If we were to tick on add velocity, all of a sudden it would give us a velocity field. Now a velocity field is three components because velocity is a direction, and that direction also has magnitude. Well, as I said before, a volume or a voxel can only hold a single value. For what's called a vector field, which is what a velocity field is, it needs three separate volumes to represent that field. It needs an x, a y, and a z volume. So keep that in mind. You can't just store all three values in a single volume. So this will give us some upward velocity. I don't think we really need that, but one of the things that we do need is some curl noise. This will just add some turbulent nature to our initial velocity. The scale is again our amplitude, the swirl size is our frequency, so we could turn that down, and this is quite large. We could probably take this even smaller, something like that. And if we hit play, you can see this is what it looks like, and because animated is ticked on, it will vary over time. If you don't want to see these streamers, you can just go up here and uncheck visualize. It's not going to take away the velocity field, it just takes away the visualization. And then let me also I almost forgot, set our density back to 1. Because the amount of density that is being fed in will affect the pressure solved, so just be aware of that. And let's dive in our AutoDOP network. Let's go ahead and turn the resolution up, because generally whenever you start refining your parameters, that's when you want to start inching the resolution up. And let's hit play. Because you will see difference, you'll see additional detail, etc., just by turning the resolution up. So I'm going to go ahead and let this sim. I'm just going to pause it real quick. Alright, it's finished simulating. So when I hit play, this is what we have. I'm going to go ahead and flipbook this, because as it gets towards the end, it starts to kind of chug. Your machine might be fine if it's better than mine. But one thing I did forget to tell you, if you haven't used DOPS before, is by default on the DOP node itself, it will cache simulation, and it'll be using well, basically 5 gigabytes. So I'm going to flipbook this. Alright, and so now we're getting some kind of vaporous smoke. Alright, so for the next video, we're going to take a look at emitting smoke off rigid body objects and kind of taking our control a bit further. Alright, thanks.